In this video, we're going to take a look at how to find and use multiplicative inverses. So this is going to be another method to solving some problems with matrices, but we've talked about inverse of matrices using 2 by 2 matrices, but we're going to look at larger ones today. So we're going to look at any size matrices. And notice that it only works with a square matrix, and we talked about that in class because of the fact that you can only get the identity matrix with ones down the diagonal and zeros everywhere else if it was a square matrix. This would not be a valid identity matrix because it's not square, and it would not actually result in the same matrix. And you saw that in class. So let's take a look at the basic steps. I'll kind of give you a picture of where we're headed. So it starts with making an augmented matrix with the identity matrix. So if this was my matrix I was working with, 1, 2, 3, 4, 7, 9, 8, 2, negative 1, I would take that matrix if I'm trying to find the identity of that matrix. I'm sorry, the inverse of that matrix. I would start by making it augmented. So I'd erase that 1, and I would draw my line for my augmented matrix, and I would replace the right-hand side with an identity that's the same size, the same order as my original matrix. So that's step 1. Step 2 is to perform row operations until the identity is on the right. I'm sorry, not on the right. The identity is on the left, excuse me. Right now it's on the right. We're going to perform row operations until the left-hand side has the identity. So it would end up looking like this. And then on the right-hand side we'd have numbers A, B, C, D, E, F. We don't really know what these numbers will be. That's what we're trying to find. Because in the end, that side is the inverse matrix. So it takes some performing row operations, and we're going to just make sure everyone knows how to do that. And then we'll start to use our calculator again. But first we're going to make sure everyone knows how to do that inverse matrix and finding it by hand. So let's take a look at an example. I'll leave these steps up. Let's take a look at an example. So we're taking this matrix and we're going to find the multiplicative inverse of A by row calculations. So again, it starts with taking the matrix and putting the identity matrix on the right-hand side. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Now we're going to perform row operations. So a few things I already noticed is I like this 0 that's down here. That's promising. And I also like this 1 right here. So we have a couple of things that are good right now. But we do want to make this a 0. So let's add these 2 rows here and replace row 2. And we'll leave all the other rows the same. So we're adding the middle and the top row. The top we're just going to copy down, because again we said we were happy with it where it was. The bottom we're also going to copy. And let's take a look at that middle row and what we'll get when we add the middle to the top, because the 1s will make a 0. So we'll have a 0 here, 4, 4, 1, 1, 0. So notice I also added these 2 together, these 2 together, and these 2 together. So that's the whole point. The right-hand side will transform into the inverse matrix. So good news is I've got some things started here. I'm going to maybe make this a 0 next. So let's make this 4 a 0 by adding negative 1 times the middle row. So making all these negative, well, negative 0 doesn't really matter. I'm going to copy the top row again, because I don't really need to change it yet. And I'm going to add that new middle row with the bottom row. I'm going to actually leave the middle row the same, but I'm going to add this negative 1 together. So these 2 will get added together to make 0, 0, negative 1, negative 1, negative 1, 1. Okay, so I added these 2 rows together, but really it was negative 1 of row 2 plus row 3 to replace row 3. That was my row operation. So now I have row 3 replaced. Looks like the bottom row is almost done. All I need to do is flip everything, because I don't want negative 1, I want positive. So if I flip everything, really I'm timesing by negative 1, I will end up getting my bottom row is finished. And the beauty of the bottom row being finished is now I can use it to help me get rid of some other things. So I'm going to use the bottom row. I'm going to times the bottom row by -4, add it to the second row. That will get rid of this 4 here. It'll make it a 0. So I'm going to just show my work down here, timesing it by -4, -4, this will be +4, add it to the middle row, and copy the result. So the bottom, again, we're going to just copy it down. It's done. The middle, we're going to add -4 plus 4. We're going to get, let's see, 0. The 4 will stay. It's going to be 0, -3, -3, 4. And again, to get those -3s, I added this -4 plus 1, -4 plus 1, and 4 plus 0. So now that's done. I'm going to simply copy my top row and think about what I need to do next. I'm almost done with the inverse matrix. 2 more steps here. I'm going to start with the middle row and making this a 1 because I think that will be most beneficial, making this a 1. And the way I'm going to do that is by dividing that middle row by 4. It's going to make some fractions. You'll see with inverse matrices, they often will have some fractions. So the bottom row is going to just copy, the top row is going to just copy, but I'm going to get that 1 in the middle. So 0, 1, 0, -3/4, -3/4, and 1. So my middle row is finished. Now I can use my middle row to find the finished top row because the middle row will no longer affect this 0 or 1 because of these zeros here. That's why I waited to finish the top row. But I'm going to do, let's see, top row minus the middle row. So let's see, I'll just flip everything to negative in the middle row, or to positive if it was already a negative. So just times the middle row by -1. Now I'm going to add it to the top row. Again, I'm going to copy the middle and the bottom row down because they're not going to change. We were already done with them. So I'm going to leave them as they were, -3/4, -3/4, and 1. But I'm going to add the middle to the top. 1, 0, 0. Let's see, 1 and 3/4, 3/4, and -1. Now I'm finished. This matrix on the right-hand side is my inverse matrix. So I'm going to just write it as decimals so it's not so crowded. And this is my inverse matrix. If you were to multiply this by the original matrix, you should in fact get the identity matrix, and you can use your calculator to check that. So this is a long process, but we're only going to do a few problems by hand, then we'll start to use our calculator. Here's why this process is helpful and why it's another way to solve systems. So we're going to take a look at the system, and I'm just going to show you a little example of what you would do to solve the system using this method, but I'm not actually going to work the whole example out. So remember, we just worked it out so we had the identity matrix. Now if we want to solve the system using the inverse method, some of you saw this last year, you start by writing a matrix with the coefficients again, just like we've been doing. 1, 1, -1, 0, 2, 1, -1, -2, 0. That's your matrix, right? We usually would make it an augmented matrix, but we're going to do something different. We're going to write it as A times X equals B, where A is the coefficients, X is the variables. So X is actually going to be X, Y, Z, equals B, and B is the equals, the answers, the results, 2, 3, 1. And this is a true statement because of the way multiplication works. If I multiply this by this, I do row times column, remember? And it would end up being 1x, 1y minus z, and that's why this works. So this matrix right here, if I wanted to solve for x, y, and z, I would need to get rid of the A, meaning I would want to get the x, y, z matrix alone. I would want a statement that said x, y, z equals some numbers, A, B, C. Right? That's what I want. I want to know what x, y, and z are. That's the goal of solving a system. But in order to do that, I would need to get rid of this a on this equation. So we're looking at this equation right here. Ax equals b. I need to get rid of a. And the way we do that is we times both sides by A inverse. But what's really particular is you don't times b by A inverse like this, because notice A inverse is on the front. It has to be in order to make A 1, the identity over here. So I actually need to move that to the other side. I need to multiply the left-hand side of b by A inverse, and that's key. So make sure that you are careful with that. So that's the steps you would take to solve this. You would times both sides by A inverse. We're not going to do that example. We'll do the example in class, but hopefully you wrote a couple things down, and you can at least try to answer your multiple choice and free response questions. So try to find the multiplicative inverse. That actually is what we did in class, but you could use the method I just presented to you if you want to try it. And then the free response question. See if you can explain and re-explain what I was just trying to show you and put it in your own words. Thanks for watching, and we'll see you on Monday.